All right, I'll let that go. So I want to introduce Andrew Baker, who's going to be our speaker tonight on Docker. So the really cool thing is Andrew basically wanted to know more about Docker because it's just the new hotness. I was actually just down in Richmond talking to a fellow DjangoCon speaker, and he was like, I'm trying to think of a DjangoCon 2014 topic, and I was like, you just string random words together and add Docker at the end. That's all you need to do, because everyone is just talking about it. So Andrew went the step further and actually you started using Docker and built his own platform as a service, which was in Docker Weekly, which is really cool, and actually really knows this stuff, and also combine that with Ansible, which is, I thought just sort of the combination of these different technologies was really awesome. So I'm super stoked to hear Andrew's talk tonight on Docker, so let's give him a warm hand.
Such a great introduction, thank you. It's an honor to be here, Django. So, call this presentation Docker 101. It's a brief introduction to Docker. Here's some information about me. I'm the Python lead at Excel Consulting. Like Matt said, I got into Docker because of a side project I worked on this winter, using Docker to build a little platform as a service, which I'll talk a little bit more about later. You can find me on Twitter or my blog, and here's links to this presentation in the tutorial repo, but there are going to be bigger links up there when we actually get to the tutorial part. So I just want to ask one question about to you guys. Who here is using Docker right now? All right, cool. Who here has maybe tried the basic Docker tutorial but hasn't gotten much past that? Cool. And who here hasn't done anything with Docker ever? Awesome. You guys are going to get a lot out of this tonight. You two might have a low lead. So the format tonight is I'm going to give a short presentation covering some Docker basics. Then we're going to switch into some self-paced tutorials that I wrote up in a repo online. And if you have questions anywhere along the way, just feel free to jump in and ask. So what is Docker? Like Matt said, it's definitely achieved first-class buzzword status in the tech world. So I thought we'd start off with just a basic definition. When you're just reading all the headlines about it, it's hard to tell exactly what Docker is. Is it something like VirtualBox, where it's a virtualization provider? Is it something like a configuration manager, like Chef or Ansible or Puppet? Is it a virtual machine manager, like Vagrant, which is trying to do a lot more orchestration and kind of higher level things with virtualization? Is it just fancy C groups, or maybe you've heard of LXC for Linux extension containers? The answer is that Docker isn't quite like any of these things. It's something sort of new in a class of itself. And because of that, we don't really have tech vocabulary to describe it in ways that really make sense. But an open source engine that automates the deployment of an application is the closest thing we're going to get. I think it's a little easier to explain it in terms of a spectrum of application portability. So on the left side over there, you've got environment specific. So, and that is where you're going onto a server. Maybe it's an EC2 instance where it's virtualized, or maybe it's a bare metal machine that you've got sitting in your data warehouse. But you're going in there, you're SSHing in, you are doing all the configuration, you're setting up that server to work the way you want it to. And it's not portable or reproducible at all because you've logged into that specific instance and manually punched in all those commands in the right sequence and banged on it until it worked. A little bit further towards environment agnostic are configuration management tools. So those are things like Chef and Puppet and Ansible, where you're writing code that will programmatically apply that same configuration to every environment. But to get those to work, you still need to write your configuration management code to work for the specific operating system that your servers are running on. Like if you're using Ubuntu or CentOS, you've got to use apt or yum. If you're using something like Puppet, then you need to get an agent onto that server before you can actually apply that configuration. So it's not quite as portable as people would like, but certainly a lot better than the manual configuration. All the way to the other end of the spectrum, at environment agnostic, is a full traditional VM. So if I get an export of a virtual appliance that someone made in VirtualBox, and I bring it onto my dev machine that has VirtualBox, it doesn't, as long as I have VirtualBox, it doesn't matter what is going on in that virtual machine, how it's configured, it's going to run the exact same way. But it's also not exactly the most efficient use of my resources on my dev machine, because I have to duplicate the entire operating system, the kernel, everything to get my application to run. So Docker kind of sits right here in what I think is a really happy medium, where you are working on your, you kind of Dockerize your app locally, and you're building it against a specific operating system, but it can use the kernel of whatever server it's deployed to. So you get basically the best of both worlds, where it's full isolation in terms of the operating system and your application, but you don't need to replicate all of the, you don't have to use resources to replicate all of the lower level operating system functions. So this chart explains it a little better. Sorry, did somebody have a question?
I was just going to say less of OS.
Oh, yes. that's a tiny little asterisk in all of this right now. Docker is really great on Linux, getting better on OS X. So you can see here on the left side that that's sort of a traditional virtual machine setup, where there's a server, a host operating system, some sort of hypervisor, some virtualization provider like VirtualBox, for example, and then you're running a guest operating system on top of that, and then you have all the libraries and applications you need to run your app. With Docker, it's smart enough to leverage the kernel and the lower level operating system of the server that it's already running on. So you can see when we are virtualizing our apps with Docker, we don't have to do that guest operating system piece. We can just go straight to using our application. So the phrase to use with Docker is, instead of a virtual machine, is a container. And containers are lightweight compared to virtual machines because they only contain the code that you need to run your application and the binaries or the libraries that support it. None of the underlying guest operating system. And one of the neat things about Docker is that it has this sort of additive file system approach, so that as your application evolves over time, it's in a Git kind of version control-like fashion, sort of storing each sequential change that you make to your app, so that it can just basically do everything a little faster, because it recognizes that when you're trying to deploy a new app, most of it is the same as the way it was before. So kind of bringing it all together, the idea with Docker is that you are trying to run one Docker container for each process in your application stack. So this is different than with traditional virtual machines, where you might have one virtual machine that is your entire application. So if we're talking about a Python Django app, it would have Green Unicorn running for your Python server, and you would have Nginx, and maybe like some log rotating or other kind of celery task, maybe. All those sort of different pieces that bring your app together might be in one virtual machine. With Docker, you're going to want those all to be separate containers for separate processes. And the reason why this is useful is because Docker's, by putting each of those different processes in its own Docker container, whether you're running all of those containers on your development machine locally, or you're deploying all of them to different servers in the cloud because you want them to work at a much higher scale, they're going to perform the exact same way. This is like getting at this edge that Docker has about application portability. The idea is that if you package it up in one container, one Docker image, then it's going to work the same way everywhere you deploy it. So does anybody have questions about this so far? Yeah.
You said it'll work the same way, but it has to be deployed in the exact same underlying operating system, right?
Not the exact same. It has to, right now the limitation is that it has to use a specific version of the Linux kernel. I think that's right. So, for example, the host operating system that has the most Docker support so far is Ubuntu, but everybody's jumping in on it now. So if I'm running Docker on my Ubuntu virtual machine, like you all will be in the tutorial when we get to that, you can use any other flavor of Linux that uses that same kernel to virtualize a Docker program, a Docker application. So it has to be similar enough that it can use the same kernel, so that it doesn't have to duplicate it, but it can be different enough in terms of operating system and Linux flavors that you can customize. Yes?
Does it have to be, you said the same kernel, the exact same kernel version, or just, is there like a minimal?
I think it's a minimal,
No, I could tell you that. It's either 2.6.431, anything higher than that, or 3.10. Anything higher than that. It has to be like C group enable and Linux container.
Okay.
but it doesn't have to be the exact same.
Correct. Yeah, as long as it has like C groups and all the other.
Okay, yeah, great question, thanks. Yeah,
So, I know that .cloud has completely changed their business to Docker. I mean, are they planning to do some sort of, they're planning to keep Docker open source, keep building it, and then what, value add enterprise services on top? Like, what's sort of their business model for to keep this a technology that's going to go forward in the future?
yeah, I have a couple slides on that later on, but it is really, really interesting, like the business of this whole thing. Yes?
And you may go over this, but let's say I have a Docker running, and can I take a snapshot of that like you can with a VM, and then restore that?
Yes, and maybe that'll be a little clearer once we go through the next bit. But yeah, that's like one of the things that Docker is great for. So now we'll get into a little bit of terminology, but I'm going to kind of go through it a little bit quickly. Don't worry if you don't get everything, because the tutorial piece is going to really go through all this in much greater detail. So the two kind of constructs in the Docker world are containers and images. Your application runs in a container. A container is something that is running on your server and is actually powering your web server, Celery server, or whatever you want to talk about. So to start a Docker container, you need to have all the information, source code, operating system bits available in a Docker image first. So images are saved states of containers. There's a handful of base images out there, which are basically like base operating systems that you would get, sort of the state of an operating system you would get right after you install it. And then everything that you do after that is customizing it for your application. So you're installing, maybe there's web server, Nginx, whatever. So sort of the idea with Docker is that it's kind of like Git, where you are using each kind of instance of a Docker container to change your stack a little bit to build it up into this image that is the complete application or process that you're trying to deploy. And again, I know this is kind of weird, but it might get a little clearer once we go through the tutorials. So Docker files are the one way that you can build your Docker images. So it's just a series of commands. It really is almost like a bash script, to where when you tell Docker to build your application and create an image out of it that you can take to other servers, it's just going to execute each of these steps in this Docker file until you've configured your application the way you want it. So there's this thing called the Docker index. The Docker index is kind of like the GitHub of Docker images, where if an image is like a repository, then this is where everybody's Docker images are hanging out there on the internet for everybody to use. So you can see there's some official ones for Ubuntu and CentOS and Fedora. Those are those base images that you can take to start configuring and building your application on top of. There are also, when you do some searches in there, you can see things for like a Django app or a typical like Nginx or just a normal LAMP stack. It's kind of everything. There are lots of different options out there for what you want. So people have compared Docker to Git, sort of like the Git for deployment, and it's a little bit of a rough analogy, but I think it helps people understand what's going on. So a Docker image is like a Git repository, where it's just a collection of commits over time that kind of lead you up to the desired state of the application. In this case, it's the desired state of your process, your server. A Docker container is like a clone of that repository, where it's something that you're using locally so that you can either build on your repo that you already have, or you're checking it out to a server so that you can use it to power an application in production. And the Docker index, like I said, is like GitHub, where it's just kind of this place where everybody's keeping their Docker images that they've worked on together. So does anybody have any questions on that? Yes?
Why should you trust any of the images?
Great question. So they have started putting this new feature on the Docker index called trusted builds, where for a image on the Docker index to be labeled a trusted build, it has to be automatically built by their continuous integration service. And it has to be built from a public repository on GitHub. So you can go in on GitHub and see the Docker file, the exact commands that were used to produce that image. So you can, if there's a part that you're unsure about, you can kind of piece it apart from there. Does that answer your question?
So that precludes somebody releasing, oh, here's my version of Ubuntu and it has my secret sauce in there with the backdoor into Linux or something.
Yeah, it's definitely
Because it's all public repos that it's
Right.
built from.
yeah. So you can have non-trusted builds on the Docker index. That's how it started out. And when that happened, you were right. It's kind of like it was kind of hard to tell what was going on, especially if somebody did put very descriptive commit messages in each of those changes that they were adding, for example. So that's one of those things I think they realized early on that we were all going to be suspicious about. Anybody else? Okay, cool. Oh man, did I do that? Okay, so Docker is an awesome open source success story. It was created as a side project at a company called .cloud and revealed at PyCon in 2013. .cloud was a platform as a service provider, kind of like Heroku, but you probably haven't heard of them because most people were using Heroku. So this is like a really interesting kind of way to disrupt your market, is to take this piece that's doing this sort of platform as a service virtualization and taking sort of the secret sauce out of it and then just giving it away to the rest of the world for free. One of the most obvious application for Docker is to run platform as a service tools. And so there's lots of open source ones that are popping up now. And so it's never been easier to kind of roll your own service where you can just say like git push, like my git push Flynn, for example, and then it's going to just take your code and automatically package it up in a Docker container and start it up on a server. So since Docker was revealed, it's had tons and tons of open source contributions, getting tons of buzz, which is part of why nobody's really sure what it is anymore. But .cloud is all in on Docker. They changed their name to Docker. You might be wondering now that they're out of the platform as a service game, like Matt asked, what is their business model? And from what I can tell, they are trying to be almost like GitHub, where with the Docker index. What's that?
Hosted private repos.
Yes, so they want you to pay to host your private images on the Docker index. And then I think we'll see them just kind of building out lots of other paid services around it that are just going to make it as convenient for working with Docker as GitHub is for working with Git.
They were kind of linking along as a yes.
Yeah.
We actually used them for a little bit.
The private repo?
No, as in we used
.cloud?
when it was .cloud.
Yeah.
Oh, really?
And it was just harder than a regular site.
Sure.
Yeah, I never actually tried it.
Pretty much good business with them.
Yeah, it's really, really exciting. So whenever you look at the Docker documentation, they say, don't use, there's always a big warning at the top that says, don't use this in production, it's not a 1.0 yet. So they're getting closer all the time, we're on point 10 right now.
That just makes you want to use it in production.
Yeah, I mean, totally. It's like, this is my edge.
Don't do
And as I've been like working with it and playing with Docker on the side, there haven't been a lot of changes that have been breaking things for me. But I haven't tried to put it in production either. So, yeah.
Can you select your own private repository, or do you have to use their repository?
Great question. So you can pull there's this thing called the Docker registry, and a Docker registry is essentially the service that the Docker index provides. It's like a Git, I guess if Docker index is GitHub, then a Docker registry is just like your own Git server. And that's open source, so you can roll your own Docker registry and use that to push and pull your images around. You can also just kind of do some low or old-fashioned type stuff, like exporting your Docker image to a tarball or something, and then just moving it over to the server that you want to load it up on.
There's nothing to stop GitHub from just posting Docker images as part of their service, disrupting Docker's model.
I never thought about that before. But yeah, I think you're right. They should watch out for that. So this is kind of the Docker ecosystem that's out there right now. There's lots of big names using it already, even if they're not using it for powering their their main web stack. Lots of tech that has already been kind of Dockerized for you, so you aren't starting from scratch if you're trying to run Node in a Docker container. And lots of integrations already with all sorts of continuous integration tools, and all the big operating systems are hopping on and trying to make sure that they're saying that they are Docker friendly. Everybody wants to go with Docker. And Docker is reciprocating the love, which is why we have some Docker swag tonight, some t-shirts to go. So this was a cool chart I just found on their blog of Docker Meetup groups, and you can just see it just totally skyrocketing. San Francisco is the dot all the way on the left, but DC isn't too bad. We have a Docker Meetup group, it's right here in the middle, so we were ahead of Philly, but behind St. Louis. Yeah, it's really cool. So what kind of stuff are people using Docker for? And the answer is all kinds of stuff. So development environments, there's a tool called Fig, where it just makes it easier for you to manage working with all these Docker containers in your development environment if you're going to use Docker containers to deploy your deploy your applications to production. Those of you doing the intro tutorial track tonight are going to learn how to use Fig at the end of that tutorial. People are using it to build platform as a services, like I said. The biggest names out there right now are Doku, Flynn, and Daze.
I think it's days. Like
Days?
platform.
Oh, yeah.
Like,
Yes, that's fine.
That makes sense to me.
like a thread, it's like a thread or something like that. You have to put it there, so you really
Oh, yeah. Like Madonna wrote in on that Super Bowl one time. That's good. So there's lots of action in this area, and it's really exciting to see platform as a services that traditionally been kind of like this magic secret sauce black box where you just kind of push your Git code up there and then it does something magical to make it work in production. So it's really exciting to see all of this open source activity in this area. People are using it to build continuous integration servers. Like you can imagine, this less costly virtualization compared to traditional virtual machines makes it cheaper for people to do continuous integration, which is really exciting. People are using it to make educational sandboxes. So this is the whole reason that I got into Docker. I sometimes run a intro to SQL class at my company, and I wanted to provide sandbox databases like through the cloud for all my students to play with during the class. And I tried to do it through my web host and just create a whole bunch of like backend databases for web apps. And it saw everybody connecting from the same IP and freaked out in black. And the class totally bombed. And we had to just like work with my local thing hooked up to the projector. And I was so pissed about that I spent all winter long building Docker at this site so that next time I could run it the right way. But there's another tool out there, I forget what the name of it is right now, but it's basically providing the same kind of sandboxes for like learning Python or Node or something like that. The idea is that you can provide these environments for people to mess around with, and it's for the most part safe. Docker containers aren't like 100% secure. Nobody's putting a stamp on it and saying if someone can get into a container, they can't get out to the host system. But compared to lots of other options, it's a pretty appealing way for people to kind of get in there and get their hands dirty. You don't have to worry about it. And all the tools for working with the Docker ecosystem are getting better too. So people are trying to put together GUIs so that you can kind of watch your Docker stack a little bit more easily. There's also cloud hosting is going to be a really exciting space to watch. So if your options before were using a platform as a service like Heroku to just kind of push your code up and then maybe you can move a slider up and down, but you don't really have a lot of control over how that application is being served. Especially load balancing is something that people have been concerned about a lot with these platform as a services, where when you scale up the nodes, how do you make sure that they are sending requests to each of those nodes in a way that is cost effective to you?
Did you see that rap sheet in this post?
What's that?
Did you see the rap sheet in this post about Heroku?
Yes, that one like a few months ago, right? Yeah, I thought that was really, really interesting to watch because they basically like black boxed Heroku and said, we're paying for all these nodes, but you're not really serving efficiently all of them. And they, at least in the past, had made some promises that they would. So there's that end of the spectrum, and then there's using something like EC2 or DigitalOcean where you're going to get a full virtualized server and then you have to configure all the bolts of it from the ground up. Which was great compared to bare metal servers, but now I think we're all kind of tired of like installing lamp stacks in the cloud. So hosting services where they just accept your Docker container are going to be the exciting new thing to watch. Because with Docker, you can do whatever you want to your application locally, package it up in this container, and then send it off to a service like Tudum or Orchard, and you can know that that application is going to behave exactly the way it did when you packaged it up locally. There's still, I think, some kinks to work out in terms of making that sort of scaling work in a way that's smooth. But this is a space that's going to get even more exciting, and it just kind of hits that sweet spot where I think the market is going to respond.
Well, DigitalOcean and AWS have already started offering airlines with Docker.
Cool. Awesome.
Elastic install.
Yeah, yeah. So I think, yeah, that plays great into my next slide. The things are getting better all the time. I literally added a bullet to the slide today when somebody showed me the manage your Docker containers with Vagrant. Apparently that came out yesterday. So yeah, Elastic Beanstalk support came this month. Docker is officially in 14.04. It's Docker and Red Hat have announced a partnership. So like I said, things are happening with Docker all the time. It's really, really exciting to watch. The Docker Weekly email newsletter is very comprehensive. So it's a great way to stay plugged in.
What does it mean that it's officially included? Because I mean, it's, you can run Docker with 12.04 and up, right? What does that mean?
Yeah, I think it was, they just kind of brought it into like the official app repositories.
So you can do apt-get install. Docker.
Yeah, I think you still need to like add an extra key for it maybe or something because it's not all the way there yet. But
Okay.
the idea is that it's going to be as easy to install Docker as it is like to install Apache or Nginx from app.
I can actually get clarification. The guy who heads up Canonical's Ubuntu desktop actually works out of his co-working space. So I will check tomorrow and post on the
Yes, please
on
comment.
the Meetup group
Is this
what
the-
officially means.
The head of Unity.
Yeah. No. Well, he's at Canonical. He's not with you.
But then you know Unity, you say he's a desktop guy.
Yes, he does desktop and mobile both. Which there's a mobile.
If you tell people
Anyway.
he's here, then you mention.
Yeah.
I don't like it.
Wow. Hey, I don't know where he works. So.
He's good at talking.
I'm going to take that board out of the video. So does anybody have any questions before we get to the tutorial content? Yes.
For containers, can you share them like amongst developers to like onboard new people, or is the idea that you are still, like, okay, you've got a new machine, you have to install libraries in this container based on this base configuration?
I think once we go through the tutorials, it'll be a little clearer for you. But basically the idea is you want to keep your Docker, kind of treat your Docker image the same way you're treating like your GitHub repo for your code. So that's, you want to always have, I guess, Docker images available with like the latest version of your application. And then a new developer could pull down that image, get it somehow, and then they can use it to start their own containers to start playing around with locally. Yes?
So is it, you had a slide at the very beginning where you pretty much showed the Docker file, and it was very skinny on the far right hand side. And I think what I got out of it was that,
This one?
no, it was actually just right there.
Yes.
Okay, see what it says modified app? So you have the original app, you have copy that, then modified app. So it looks like it's only doing a difference between the two original apps.
Yes.
So you start out with like BusyBox, and then you put your app, and the Docker is the difference between BusyBox and what you changed?
So it's more like the Docker image is the collection of all the changes that have happened to that box, to that container, if that makes sense. So kind of like the way a Git repository is just like every commit adding a different change to your source code, and the repository as a whole is just a series of all those changes. The same thing with the Docker image. You're going to kind of start off with a base image, like some base operating system, and then each little piece that you add is an additional little sliver here. And you'll see it when we start going through the tutorial, because when you pull down an image from the Docker index, it's going to pull down a different layer for each change that's been made to that image.
So is the change a text file that you can see, or?
You can see the collection of changes in the logs for the image, but the change is anything that happens to the container. So if you're adding a file, if you're just like touching a file, if you're even just echoing something out, it's technically a change.
Okay, so let's say you have a Docker, and you're gonna apologize about it.
No, this is fine.
Let's say you have, let's say a Docker container, and a hacker gets it and makes a modification. You then go back and roll back the changes?
Yes. I haven't gotten super involved with like that kind of complicated, or it's not complicated, but you have access to all those previous images, so you could go back and then kind of, I guess, sort of start building on top of it again after where it was bad.
It also depends where you freeze your images. So you freeze your containers and images.
Yeah. Yeah. Let's, I don't know, I'm going to stew on that one a little bit while everybody's working. That's a good question. Yeah.
It seems like, I mean, most of the true passes that are out there now, you really don't care whether it's Ubuntu or whatever the OS is underneath. You just want your Python or your Ruby code, just squirt it out there and it runs. You know, it could be Windows. You don't care. And that's a good thing.
Yeah.
This seems like sort of getting back to, okay, it's got to be Ubuntu, and you got to be using this version of Apache, and you got to be that. And that seems like kind of a little bit of a step backward.
Yeah.
But the nice thing is they start up really fast, and they're really lightweight.
Yes. Yeah. That's.
So I kind of like code independence. I don't care what OS is.
Yeah. I definitely think it's a spectrum where, you know, if you don't need to get into like the server mechanics, then platform as a service like that is probably totally adequate. And Docker is still good news for you because all this disruption that's happening in the market. But if you do want to go like one level deeper and maybe get into those like web server configuration type things where you're worried about performance or scaling, I think that's the sweet spot that Docker hits, where I can configure, you know, like Nginx and how that's working, which I can't do in Heroku, but I don't want to configure all the rest of the operating stuff like I have to with EC2.
Maybe the ecosystem will evolve to where you just like plug and play across the components, and you don't have to care what they're really running on. That's pretty cool. I can just work on my app, and I'll be able to use Mongo over here and whatever web server over there, and load balancer somewhere else. That's really sweet. But I guess the other thing I think PaaS is like the way forward for a lot of customers who don't want to manage their own infrastructure.
Yeah.
But the mature passes that were out there have fairly bulletproof infrastructure. If a physical system or virtual box like Heroku's running on Amazon, if the virtual box Heroku's running on goes belly up, their stuff migrates away, presumably, unless it's like 2 years ago. That is what Docker, I think, really needs to do to make people believe in it as a production service running on bulletproof infrastructure.
Yeah,
I totally think it's really cool to have a batch pass, but I wouldn't use it in production.
Right now, like with the AWS Elastic Beanstalk offering, it sounds like you get that because they will spin up new AWS instances.
Yeah, I hadn't heard of that until now, so that's
So
really
you
cool.
can have like unhealthy hosts, and if that conditions change.
Yeah, but I can trust AWS to provide the EAS that my Docker pad runs on, and that's pretty effing cool.
That definitely, that's hard to test and make that bulletproof, but it's probably why you use Docker in the previous Elastic.
Yes.
But also, everything in Docker is like communicated over sockets, so like it doesn't matter if it's on the same box or it's on different boxes. I think that we'll start to see like orchestration and stuff around Docker like pretty soon.
Yeah, I'm whining, but it's really case for Docker compared to anything else that's out there.
Totally. Yeah. I guess I should also say the disclaimer, you should not use this in production.
It's like competitive edge.
Here's my big red one.
Everyone's bluff has just been called.
Okay, cool. So we'll